could turn that one theorem around to show if it wasn't bounded and monotonic, could I conclude that it's divergent? Here I have for you what's called the nth term test for divergence. And what the actual theorem, okay, don't write this one. Don't write this one. But this is theorem 9a. And it says that if the sum converges, the limit of the nth term has to be a 0. The theorem stated this way is useless. If you knew it converged, you're done with the problem. But if you take this and form what's called the contrapositive, and you don't have to write this either, but this, if you take logic class, we start out with a hypothesis, P implies Q. It's contrapositive, which is not Q implies not P, is logically equivalent to the P implies Q statement. It's a lovely study sometime if you ever get a chance. But here's the one I need. So this is the contrapositive, and the contrapositive says if the limit as n approaches infinity of a sub n doesn't equal 0, then, and then the negative of that is then a sub n diverges. So this is the one I need you to write in your notebook. This one is the biggie. And this is the direction you use it. You cannot prove convergence with this theorem. On the test, it's going to say, does the series converge or diverge? What can you quote to me to back up what you're saying? On a geometric, all you have to do is quote that the R value is between 0 and 1, absolute value of it. For others, you're going to want to quote this, but this can only be quoted to conclude divergence. So now, suppose you looked at
do we have to say just theorem 9.8 or just that if limit a and
it's
n
really,
equals
its
0?
name is really the nth term test for divergence. That's what people say.
Okay.
Nth term test. Nth term test. So suppose you were trying to answer for me whether that infinite series of n factorial over 2n factorial plus 1, does it converge or diverge? You're definitely not doing partial fraction decomposition on it because we don't know how to factor that n factorial into something. And you can't be cute like we were earlier today where we got a whole bunch of stuff to cancel out. But what we can do is take a look at the limit as n approaches infinity and do old Calc 1 to it. Divide by the highest, actually it's not a power, it's a factor. We'll divide everything through by n factorial. Yes! No! The whole big deal is the limit didn't equal 0. You should should be jumping up and down. Oh, it diverged. I can move on to the next problem. So this thing diverges by nth term test. Nth term test.
So if it has,
Why
so
was
even
it
if it
okay
has a
before?
limit, okay, I'm confused, so even if it has a limit, but just because it doesn't equal zero,
Yeah?
so but before in other problems, when they didn't equal zero, they were still converging at whatever the limit was.
But those were sequences with commas in between. Here I'm adding stuff up. And if I keep trying to add up an infinite number of 1/2, say, how long is it going to be before that blows up in my face? So what I need is the tail end of these terms to get teenier and teenier and teenier so that when I add them to the front, it still makes a finite amount. So yes, if you're just looking at a sequence, and those commas in between, and they all start to look like the number 4. Everybody's happy. But when I turn it into adding 4 plus 4 plus 4 plus 4, pretty soon it's infinitely large.
I see what you mean.
Yeah, I need them to zero out.
What's the difference between this problem and the other ones that we were doing? Is that what he just said?
No, which others would you like to look at?
Like we did one earlier where it was a